Hi, everybody. It's Tricia Cease here, president of the Virtual Foundry. With me, as always, is Brad Woods, the founder and inventor of Filament. Today is Friday, February 5th. It's 1:42 in the afternoon. The temperature outside is 10 degrees Fahrenheit, minus 12 degrees Celsius. It's a very chilly winter day here in southern Wisconsin. We have a lot of snow on the ground. There has been a lot of activity around plowing snow. We are headed towards the spring, though. There's light at the end of the tunnel. In today's podcast, we're going to be talking about the distributed development model. Here at the Virtual Foundry, we're relying on a distributed development model. It's the nature of open architecture product development, similar to RepRap and the origins of 3D printing in general, where the idea of something is introduced and people take it and make it better. So, Brad, talk to us about that a little bit.
Right. This has been a recurring theme in technology since, since probably in the 60s, and starting with the internet itself. ARPANET, the original version of the internet, was released as ARPANET. So it was it was a government defense project. So they laid a framework that millions of people have developed technologies around. They essentially created a platform and set it loose, and it's changed pretty much everything. And similar things happened with desktop computing. It followed a parallel path, starting in the early 80s and then really gaining steam in the 90s, where it was home users assembling parts and taking everything to the next level. The Virtual Foundry has a similar strategy. We make materials, but we don't necessarily follow the development cycle to completion. We do examples. We've done this with copper, our key materials, copper, bronze, our stainless steels. Each of those we've developed and published information. Much of the information, actually, though, comes from sort of our super users, the people who really, really became involved in the process and decided to take the technology further. In fact, some people are building businesses around this, and this is becoming more and more common. And it happens everywhere from in people's home shops and their living rooms to the national labs. NASA, we have moon dust development projects, just all kinds of crazy things that you wouldn't think would be going on. But what the Virtual Foundry does is just creates a platform for people to develop new 3D printing technologies and materials.
Now, one great example of a super user developing a business around this technology is Sapphire 3D. David Lawson at Sapphire 3D started as a customer. He bought some material, he got himself a kiln, he started experimenting with it, and then ended up becoming a really great partner to the Virtual Foundry. So he has actually been the one who took the early sintering process that we had, worked with those, really refined those, and his instructions are the ones that are published on our website now. So started as a customer, took the technology further, and now has become a great partner.
Right. In the example of Dave, we had created sintering profiles that didn't work consistently. We would get fantastic parts sometimes, but not always. So we knew that the answer existed and the solution existed for the problem, but someone needed to stop, take the time, and do the testing and the scientific method of formulating a consistently repeatable strategy for sintering those materials. And that's what Dave has done.
So one really fun part about this distributed development model is that we end up with a community of users, a community of customers, and we're all working together. So one way that we work to help people along, sort of a help you, help us kind of a thing, is that we publish our sintering instructions, or we publish as much as we can for free about how to use the materials. We don't make you look for that. We don't make you ask us for that. It's just right on our website. So if you buy some filament, you can take it home and you've got full access to the instructions there. We're not trying to monetize that process. So we're providing that information so that everyone can work with it. As Brad said, what we have here is a platform that enables further development and development into hundreds, if not thousands or hundreds of thousands of different applications.
Right. And we have users developing in areas, things like aerospace. There's a lot going on. Titanium was a really hot topic this week. It just came up over and over, and it's used in aerospace, and it's used in, human body implants and things like that. So on the extreme high end, we have people working with multi-million dollar sintering equipment, and where it's nothing but they do nothing but sinter medical grade devices. Previously, it's always been done using more traditional sintering techniques, things like pressure sintering or press and sinter and things like that, and some in metal injection molding. Now, the virtual foundries concept becomes another entry point for for people to solve problems at that level. So they're solving problems that were literally just not solvable before.
Now, if there's any downside to this model, it might be that you're not getting a finished process necessarily. Now, you're certainly getting a finished process. It does need to be modified and tweaked to your own variables, your own hardware. But what that means is that we can be in communication with each other. The Virtual Foundry Sapphire 3D we're partners with our customers. Their success is important to us on a personal level. So we're really working closely with people who are using our products, and that's frankly one of my favorite parts of this work, is being in contact with all of these really fascinating people doing these amazing things out in the world.
Yeah, we have inventors from all over the world trying unique things in their home shops, things like that. The variety of users is astounding. The variety of industries that we're now touching is beyond anything that I could have imagined when we started. We'll talk nuclear physics, radiation, and aerospace in 1 week. We'll have a couple meetings in those different areas. And what we're doing, what Tricia and I do, is we ensure that those users are able to 3D print the parts. We don't necessarily hold their hand through the sintering process. I mean, we'll provide any information that we have. It's all freely available. But in some cases, we'll connect people with a sintering service, or someone else can do it for them. And Sapphire does that, or printing service and sintering services. Or, like I mentioned earlier, just high-end sintering, where they do nothing but highly chemically stable medical devices.
So the name of the game here is encouraging experimentation, being development minded, putting the material through your process and seeing what comes out, making adjustments and working again until you've got the most beautiful piece you can imagine.
Right. Yeah, and keep moving it forward. And one key thing to understand is that the Virtual Foundry is a materials company. We have 14 standard materials right now. We've probably made about that many custom materials for a variety of people in all kinds of different applications. Some with powdered materials that we didn't exactly know what they were. We all knew that they were safe, they said. And so we will continue to do that. We're going to expand the scope of the materials that we make into filament and make available, and we're going to let the community solve the detailed problems of the sintering cycle.
The other benefit of being in such close contact with our customers and our users is we have this immediate feedback loop. So we're getting immediate feedback if anyone's having trouble with printing, and we can help them through that process.
Yes.
We're getting immediate feedback if anyone's having trouble with sintering, and we can help them through that process. We're getting immediate feedback on people's results, and sometimes they send me pictures, and I love to see those. And we're getting immediate feedback on the possibilities that people are coming up with of things to do. They're using a part currently, but gosh, it would be great if it could be lighter weight. Can we make a filament that serves that purpose? Most likely, yes, we can.
Right. And most of those discussions start with, well, I've seen that you did this. So it's pretty, I think that if you can do that, we can solve this other problem. Can you help us through that? A lot of that goes on here.
So what we're really generating here is a community around this brand new technology. It's about 5 years old now, but it's still in its infancy. So we're developing a community around this brand new technology, a democratization of manufacturing throughout the entire world.
Yeah, and as it stands, I mean, we have material on pretty much every continent, maybe not Antarctic, but we've shipped all over the world. We keep a map with pins in it of the people that we're talking to. And it's also just interesting to get those people's perspectives on the news of the day or something like that. Speak to someone in Belarus or wherever, just all over the place.
I always like to know what temperature it is, too, wherever the people are who I'm talking with. Weather is fun.
Right. We were talking to somebody in the Ukraine last week, and they took their laptop and showed us what it looked like outside. That was the first time I've ever seen downtown Ukraine. It was amazing.
All right, so we're relying on the distributed development model. It's worked really well in other industries like home computing and 3D printing, which is an industry we're a part of, in finding our niche in metal 3D printing, specifically FFFMetal metal 3D printing. So just really looking at a community of people moving this technology forward. It's been very exciting. I love being a part of it.
Right. The other thing that's happening is people, and we very specifically decided not to focus on the hardware part of this endeavor. We provide it, but it's just to make things more easy for our users. We'll sell it to them. But the 3D printing community is improving things so quickly that there's no way we wouldn't want to get involved at that level. But all the new innovations with 3D printing have a very positive effect on our materials at the same time.
Brad, I have one more very important question for you before we wrap up today's conversation.
Uh-oh.
Why do we tell actors to break a leg before they go on stage?
I've always wondered that. I do not know.
It's because every play has a cast.
All right, a pun.
Well, thanks for tuning in, everyone. That wraps up our podcast for today. We look forward to seeing you next time.
Thanks, Tricia.
Thank you, Brad.